Chipper and Aeromarine reporting from Olomouc, Czech Republic, where we're going to have a bunch of short clips of all the action going on here, where we make mostly design work and a lot of the parts, not so much assembly. You'll see some of that, and we're preparing some airplanes for the Thunder Fun show. So we're going to just throw together some clips so you have some idea of what things look like. So keep the film running, and we'll come over here, and where Yurka is putting together some pretty cool throttles. And I'm going to show you this one because it goes into the Merlin light. And I really love this throttle because it's a one-hand operation for both brake and throttle, because we have hydraulic brakes, steerable nose wheels, so one action on the brake lever will activate both brakes. And you can do that independently of the throttle, or if you want to do your run-up, you can put the throttle on and the brakes, and you can do all that with just your left hand while you have your right hand on the stick. Or you can hold the brakes for full throttle and then release the brakes and have your spectacular 3-second takeoff. So I really love this very complex mechanism that comes with every one of our aircraft. And we scale it up to a little more sophisticated aircraft. And you'll see a little bit of that. It's not an airplane I'm bringing into the stage now, but it will be soon. We'll take a quick look at a low-wing 2-seat, a little bigger than LSA. Come over here, Dave, where we've got dual controls. Take a film of the inside of this cockpit, and you can see a very nice dual controls and a big roomy cabin. And that's for the Mosaic, the new LSA rules for bigger aircraft that can carry more and be more sophisticated and have more horsepower. You're doing a bunch of different segments because this is not your normal airplane factory like I used to have with big halls and real organized production. It is organized, it just doesn't look like it because it's a 4-story building and stuff is in all sorts of different places on different floors. And again, it's mostly building components, not a whole serial production line of aircraft. But there is a lot of production still going on, and you can see here where we have the 2-seat Merlin, that we have 4 of them work in progress. And if you come over here, we already have a launch customer for this one, and we're just getting some of the airplanes out of the way downstairs that are going in a container next week, and we can start on this. And this is one we're planning on putting a bigger V-twin in. And the 2-seat Merlin, if you take a look at this, David, by the way, I didn't introduce my son here, Davey, who's studying in Czech VUT in Prague and came down for a few days to help out. And this one has the dual yoke controls, but you also have dual stick controls. So that's an option. And this, as for an LSA, is huge, big baggage, big seats. Cantilevered wing, easy to get in and out. And with the V-twin, this is going to be half the cost of some of the LSAs out there, and more efficient and better performing and easier access than most of them as well. Then some rear fuselages and some inventory, and we'll move on to the next department. One thing you haven't seen, and we won't, is an off-site facility where there's about 7 or 8 CAD workers. They're the ones who take a rib sample, a cross-section of a rib, and a cross-section of a forming block, and a cross-section of the skin that it goes on, and they actually form it with their hands because it's just small, or a little rubber hammer. And they get that position of the hole perfectly from the flat sheets that end up going to be a bent sheet, and you're going to match together, and you have a whole section like this. They're all these to match. It's all done in a controlled environment on tables right next to the Katia 3D CAD software, the most sophisticated software for aviation in the world. And a half dozen or more people are in there programming all day long for different projects, for new drawings, for upgrades, for all the stuff I keep bringing to Martin to do. And And then there's another CNC cutting machine, which you haven't seen, that's actually making all these holes. And then a third one that's cutting all sorts of different parts. So you're going to miss that part, but that's pretty common. We do have a couple engineers here, a couple workstations. Something like Bonnie, and she is becoming here. She really knows what she's doing with CAD work. Come on in.
Oh yeah. So this is
and you can see that she's making something we can't tell you about. And one of the servers, and she has a clone. And when they're both here, it gets really confusing. So we'll make a wrap there. So the big question is when more Merlins will be coming. Well, we have stacks of them already in USA, and we're finishing the installation of the V-twins. So there'll be a lot of Merlins flying this year. And production of the next 8 Merlins is well underway. All the parts will be made here. And if you look here, this is center spar. And that's one of the last ones. We've got a stack of them here. Quite a few of them. More than 8, and a big stack of the wing spars. So all these components with solid riveting and welding and laser cut steel and the composites and basically, and all the form parts, basically everything is being built here in the Czech Republic, kitted up, not as a classic kit where you get a box of parts, but to our assembly shop, which we're setting up in Mobile, Alabama at M Squared, and have our internal manufacturing where we can build these parts into either quick build kits or, for the most part, finished airplane, which is mostly what the customers will be taking, because then they don't have to deal with painting and final assembly. Just they come down for a few days in our build center, finish the aircraft. But we do have a lot of parts being made, and you'll see how that's done over the next few segments as we crawl around this facility. Spars in production. Unlike that massive rivet machine, this one is plenty big enough to make these AN4 rivets. You can see it. Again, the quality of this is perfect. It's level on both axes. Again, the QC rate, and then rivets are done perfectly. They're done with this machine. It's a lot easier than the hand pounded rivets, and a lot more accurate. And you get perfect quality rivets. And another thing about the Merlin is because it's all done on precision CNC, every center spar will match every wing spar. Obviously, it has to be left on left and right on right. But if you ever have any issue with the damage on your wing or a hanger rack, or want to change wings out or put a long wing on instead of a short wing, it all fits perfectly. It's spot on. That's a wrap. Okay, go ahead.
Okay.
Okay, so when you need a part number that has a forming block and a project, and you put in the computer, and this huge machine, come over here, look at the different layers. It's got dozens and hundreds of different layers, and in a few seconds it brings up that tray with that forming block and the tracking number and part on it. Because just imagine if you have 10,000 forming blocks, the amount of space that would take and how to find those parts. That's something I never really thought about before, because we never had that many making just the sport cruiser or a Merlin. We'd have a few shelves full of them, but not 10,000. Well, this is a really impressive machine. But keep the camera rolling. There are dozens and dozens of machines in this building, scattered all over. Some are in the basement, and so big they had to be built on that position. So here we have the two presses, and this is one of at least four 3 or 4 meter press brake, and another is a 250 ton press over there, which is a hydrocore press, meaning there's rubber. So let's take a close look at what our friend Kuba is doing. So keep it always level here. And sometimes the tool is all over the place. And it's computer controlled, and sometimes you're doing a leading export, sometimes long flaps, sometimes just short parts, multi-test parts. And everything needs to get formed one way or the other. Here's a pretty sophisticated little piece, and everything is absolutely perfect. And again, with our precision match hole technology, these holes are punched while the metal is flat. And then after it's bent in two different angles, the holes will still match the mating part perfectly. It's really quite amazing. So we get a lot of parts from where we do the CNC machining. And so we've got big stacks, tons of aluminum, and it gets CNC cut and bar coated or QR coded, and then brought into the bending area, which is where we are now. In that bending area, it's spec. Dozens of tools, dozens of forms. Just telling you over here for this one. This one we'll see later when we're forming. You can see this pretty sophisticated tool with the flanging built into the tool to build a bulkhead. You can see the drawing for that. And again, all the holes are punched in prior to bending. And here's a stack of, these look like Merlin ribs. And they're about the right size. Lots of sophistication in just a flat part. And then the forming block below it, and that has position holes and the lightning holes, and it's a 2-part, and then it goes into the rubber press that has extra rubber placed on top of it. And it's squeezed until the meter up there gets to 200 tons. And when it's at 200 tons, the part is formed. Pull it out, and with the very little high tuning to bending, it's ready to go into the next stages, which is 2C, and we also do epoxy priming. We'll get to that next. This little section right next to the spars, look here, there's fuel tanks, vents and caps already in place. All that work is done before it's welded together. And you can see that going together here. And then it's going to be sealed and pressure tested. And then we have fuel tanks for various aircraft. All right, we're going to put Davey to work here. We have VDO fuel gauges in the panel, and they're already wired up, and today we'll be putting in the fuel senders into the wing and calibrating it to show full and empty. But there's something else on the fuel gauge. It has a light on the top, and if we pop this out, you're going to push pretty hard and you can pop out the light, and you can wire this light to be lit with your panel lit, but that's kind of silly in an ultralight. You don't really need a lit panel. You're not doing IFR night flying. But you can wire it a different way. You can make this bulb with a little colored condom, red or green. What we're going to do is we're going to color this red. We're going to hook up one stud to the positive circuit and another one to the fuel sender, a resistor that will close the circuit when the fuel resistor gets to the minimum voltage, which is very close to empty. When that happens, the light will go on and the color will be red. So when your fuel gauge is not paying attention, like in your car, you go red. You either switch tanks or land before you run out. And here we have a left and right fuel tank. For an ultralight version, that fuel would be 8.5 gallons. That's more than it's allowed. So you might not have both connected, but we do offer both tanks. So you can choose to have 4.5 gallons, which is more than 3.5 hours of flying, which is much more than the ultralight missions usually are. Or you can add a second tank and fly it as a motorized glider or a experimental amateur build and fly until your bladder bursts. You can choose. So we'll do a little step-by-step wiring up of the low fuel warning light. Another feature that most ultralights don't have. In fact, let's just do that real quick. That what this airplane has, I'm not going to be bashing any competitors. I'm just saying that we're raising the bar. I'm just saying it is what it is. We have a windshield, we have a door, a window, and a baggage area, and a normal control stick, and full free access, and a liquid-cooled engine, an electric trim, an EFIS, and GPS is an EFIS for ground speed and navigation, and room on the panel for your iPad or your Android tablet, so you can have moving map, or your phone like I use. Hydraulic brakes, beautiful throttle brake mixer, and room. It's roomy and comfortable, and you can add cabin heat, and you can see in the front there's even a defroster. Yeah, the truth is you really don't need a defroster. What kind of flying are you going to do? Cabin heat's nice for some people. That's easy to put in. And pretty big tires for the size of the aircraft. You can go bigger than that, but this lands so slow that's going to handle just about anything. That's raising the bar of ultralights. That's a wrap. Okay, we've assembled what we need. The operation we're going to do today is we're going to remove the light from the PDO fuel sender. We're going to make it red or green instead of white, and it's very sophisticated. You get it wet and you slip it on, and sometimes it goes on right, and there it is. And then we'll put that back in the gauge, and then on the gauge itself we're going to wire the sender from this to one terminal, and the sender from this part here on the wing to the other one. So we're going to run one more wire. We've got all the wire here. We've got the shrink wrap, the soldering, the solderless terminals. We'll splice into the power for the gauges. And then we can't quite connect this directly because this is going to be in the wing tank, which is out here. So we're going to hook this up to test it to make sure it works. And then we're going to install this in the wing and then make a short lead that we can plug in, not just the two that are in there now, but the third one for the low fuel light. Cut. Okay, so once there's an order for the worker to know how many parts to make, I'm going to stack of the flat sheet that's already CNC or a short punch pressed out, and a forming block which came from a big storage machine, and then you can see it's a two-part forming block with position holes and a part number and barcode, and then all these parts get made and the part number put on, and they're all perfect. And it goes back here to the QC and then the return inventory and then the paint shop, and for the barcoding to be put on each part so it can be tracked, so we know who made it, what, and when it was made and where it goes. Quite a lot of parts. And every day this is filled up with parts. Tech Pro Aviation is making, of course, the Merlin light, and quite a few other parts for a variety of Czech aircraft manufacturers. So it's their expertise. So let's take a quick look. This is Merlin light number 1, which is already in the video because I've been flying this. And I told you how impressed I am with how it flies. At, I don't know, some 4,800 RPM on the bleeding, that's got to be about 40%, or even 30% power, which is maybe 12 horsepower, to maintain a flight at 60 miles an hour. So this is perfect for electric. And we will be making the electric power will be a plug and play. It'll match the same pickups on the firewall. So come take a quick look at this. Give you a quick tour. It's definitely not your 80 ultralight. It's all aluminum, all natural technology. Cantilever parachute here, that's optional. Nice door, windows, baggage area. I'm putting in today no warning light on the panel, but the panel is all done. And I've already described that in a previous vlog, but I'll mention it again today. We have an EFIS, a USB charger, electric trim, 2 fuel gauges, engine monitoring, engine start, the mag check, the nice throttle and brake system. And this one's got an extra tie rod in here and an extra control because we're including the pickups. You can take a close look up here. This fitting, and so every Merlin can be quickly converted to either electric power or float power or both, because this is going to be an efficient, light, ultralight, float plane, electric, even a motor glider, even qualifies as a motor glider. That's a lot for one airplane. Take a look at this engine installation. We have it's a magneto on one spark plug. A separate circuit is electronic ignition. So you have dual ignition for 2 different sources, and you have a clutch on the propeller because the engine's made for powered parachute, and so you can start the engine indoors, even in your hangar, and the prop won't even be moving. It's a very nice engine. It's one of the most popular ones used in the powered parachute. And Fleet makes tens of thousands of these. Of course, it's winter, but we're using this. We have so much speed that we just have this NACA vent, and there's plenty of cooling. We have so much cooling that I've already put the thermostat in here to be able to control and get the engine a little bit warmer. So it's not going to be a problem to cool this in the summer. And we have hydraulic brakes, lithium battery, and it's simple, clean installation. It's a beautiful cowl. And we've already done the calculations for electric. So that's why the nose is a bit long here, because the engine's so light. The electric's even lighter, so we can put most of the battery right here on the firewall. Plenty of room for all this. So I just need to make a lot of these. We're going to have a lot of orders. We already have a bunch. And so we'll add to the field later in the week. We're actually going to put the floats on the second Merlin light. And we can take a quick over here. We'll just walk right in here. This is another Merlin getting ready for shipping. And you've seen this already flying, and we're doing some prototype work on it now. We're just going to skip by this because I don't want to interrupt their work. We'll come back and take a close-up of the panel, and we're doing some changes on the engine to make a little bit better, to orientate this thrust bearing more in line with the exact thrust of the airplane. And we're putting in a fuel flow to measure that and relocating the pressure regulator. And the Merlin light wing, beautiful wing here. And again, I keep saying it's a work of art. It is a 3D tapered glider wing, basically, with this huge flap, so we can have great performance, great economy, and still meet that 24 knot Part 103 stall speed with this monster 3-hinge flap. So this is just sophistication at a different level for ultralight. There's nothing like this in the ultralight or even in LSA. There's very little like that in LSA even. All precision natural technology, all perfectly tapered. Even the flaps and ailerons are tapered. We'll be putting the fuel senders in. Besides making the film, David's going to put them to work. I love slave labor.
Oh my God.
Then the other part of the paint booth, let me put the lights out here. Oops. Over here. The other part is where those parts that you saw being formed now get epoxy primed. You can't touch them, they're all prepped. There's an important part of the prepping. There's a machine just to prep the parts. And I've never seen that. I never had that machine. We just used manual labor when we wanted to have the parts cleaned and prepped for painting. I'm going to show you that in a bit. But there's so many parts being made. A lot of these are for the Merlin. And they're all going to get painted. Everything inside the Merlin has got that green paint. It's not zinc chromate. It's better. It's a two-part epoxy. So it's perfectly protected for decades. So this would be a good time to cut. This is my least favorite room because I really hate smoking, but we got to come in here for a little bit because the electrolyte is the Merlin light. The Merlin light has the Pliny two-stroke engine, 38 horsepower. We're going to we are going to make a plug-and-play option for it, or buy the aircraft with pure electric. We've trademarked the name Electrolyte, and so not to be confusing with a different name, it's the same airplane, probably the same cowl without the holes in for the exhaust and cooling and the radiator, but the 30 kilowatt electric motor we had custom made for it in Shenzhen, China. Oh, it's quite heavy because in order to get efficient power with electric, you can do it with RPM, or you can do it with lead copper. You need a certain RPM I mean, this is an airplane engine, it's not that heavy, okay? But it's heavy for an electric motor. It's not a drone motor, it could be a drone motor, it depends on the size of the drone. But a lot of the other aircraft that I see out there are just getting these smaller, 10, 14, 15 pound motors, and they spin too fast. That gives you some thrust, but it also makes the aircraft sound like a lawnmower. It's not that good to spin a prop above 3,000, 3,300 RPM, or especially above 5 or 6. The tips go faster than the speed of sound. You get a nice quiet electric motor with a screaming propeller, defeats the purpose. So we have that, and we know the CG, we know the position, we have the cowl, the engine mount will have the same pickups. It'll be a plug-and-play change, and because that's clearly lighter than a Pliny or any two-stroke gas engine, that we can still put it in the same spot and put most of the battery, if not all the battery, right in the firewall and have a good CG. Now this is a custom controller we program. We can program this remotely and make it perfect. And it comes from Canada and it's matched perfectly for this motor. So these are the two main components. And then there's a lot of other stuff in here. These are the same batteries that Tesla uses. And I don't want to say it's 18650. I don't want to give you the wrong part number, but they're Panasonic, and I believe they are. I'm not just going to quote. We have a few thousand of these, and we're not buying a pre-made battery pack. We're making these custom. We have our own spot welding machines, our own technology, our own battery packs that we made perfect. Our target here for the Electrolyte is 9 kilowatt hours of battery. We have all that battery. We know what to do with it. We know how to make this. I've been doing this for about 7-8 years, and I'm not going to get into the politics of electric, like coal-burning cars. I should have said that, but I did. But in fact, I don't really believe electric aviation is ready for prime time in bigger aircraft. There's just too much weight in the batteries. But for an efficient ultralight like the Merlin light, to fly low and slow or as a glider or to be, I mean, John Moody and I, when we flew the cross country for 3.5 miles from South Lakeland to Lakeland for Sun and Fun, we climbed to 1,000 feet because we're flying 2 strokes and we always want to be able to land somewhere. And that's how much we trust 2 strokes, because we started flying in the late 70s and early 80s where we've had dozens of off-field landings. Flying electric is completely different. It really is comfortable, smooth, quiet. You can fly low and don't worry about it. You can talk to people on the ground as you fly past. You can put it on a float plane and not alienate all the neighbors on the lake. So maybe we'll make a whole nother film just on electric. That I want to have at Oshkosh this year. That's a wrap. And a small composites shop. And this would be the composites table, but most of that's outsourced now, so a bunch of parts are here. And a bunch more shelves here, and a bunch more parts. Not sure what they're for. Oh, there's another lift crane here. That's nice. For these 2 kilo parts.
Jeez. 2
Okay,
kilos.
moving on.
Think this is for 2 kilos?
Moving on, yeah.
Cool stuff.
Yeah. Okay, go ahead. So this is kind of like a surplus room. There's a couple of them here. We've got a lot of wheel fairings. This is for the airplane, the Merlin out there, and here's for the next Merlins. And painted now. We have the float struts and all the fittings. You're going to see those installed at Sun and Fun. A variety of other bits and pieces. More wheel fairings, more strut fairings, all finished. We have 2 struts, and we just put the Merlin light. I'm doing the wiring on the tail, and when I'm waiting for connectors. This is for the Merlin light. It's already got the connector. That's for Merlin number 1. We'll be taking that out to the airfield and flying it soon. So there's another storage. We could just skip that. There's just a lot of extra storage. Here's a reduction drive. And move on. Okay, ready to roll?
We're ready to rock and roll.
Okay, Tech Pro is vertically integrated, means we make just about everything here. And rather than take a flat piece of Lexan or polycarbonate or acrylic and rivet on a window, we give more elbow room, and we custom form that window to match our doors and our sides to make the airplane even bigger. And we do that with a vacuum heat machine. So we take a flat piece like this with the protection on it, and again, even the plexi is CNC cut, and the holes are already CNC punched, and then it goes on a forming block into the heat and into the vacuum, and it gets sucked down and makes a nice bubble, and then it gets trimmed and ready to install in the aircraft. So how the hell they got this down here, I don't know. And yet they have a brand new machine here, which is going to do a lot of the same stuff with the smaller parts. And again, it's a heat vacuum press that we'll be making tooling for. It's brand new. It'll be in operation soon, and it'll make a lot of nice form parts for us. And then there's another one back here I didn't even notice. So, great. I have no clue what that does, but I'm sure it's important.
Nice. Cut.
Okay.
A rolling press.
Start the film. Yeah, I probably haven't seen this room I know I have seen it recently, but every time I come here, I find more things. This is a shrinker, and that's if you have a piece of metal like an L extrusion that has to follow the contours or the shape of the fuselage, that you can actually bend it, not just over your knees, but just bend it a little bit and make a perfect shape. These are custom-made machines to build, make or test something. This one, I think, I built one like that in my shop that would bend the forks for landing gear, so like the nose wheel. So they're just little, and here's another hand shrinker here. That one is a pneumatic, but you need to put a bend in a piece of extrusion that's difficult to bend. You have tools for that. And this factory has tools that, I had a huge factory with 250 people. I'm not sure I had this many tools. I probably did, but they have everything here. And here's a roller where you want to take a piece of flat metal and make it curve. You do that here. And that's some type of bending jig. I can't tell exactly what it does. There's another, and that one in the back is a beater. That's where you can take the edge of a metal that might be a fuel tank and put a bead in it before it's welded. And that's a stress relief bead. It makes the tank a lot stronger. So that's done by hand. You can see a crank on it. That's important. And the flat table here for just work control a piece. Here's another forming jig. And then the flat table rubber hammers if anything needs to be fine-tuned. Okay, next rabbit hole, moving on. When parts are made, especially the skins, this is an efficient way to store skins so they don't get damaged. And again, it's mostly for Merlin, but other projects too. And there's a lot of places I don't even know about. I keep discovering new little rabbit holes in this place, and we're storing more tooling and jigs and machines. We'll keep the film running. This machine's a bit loud, so we're just gonna have a look. This is where you take these flat parts out of the CNC machine and you run them through this dishwasher. It's the biggest dishwasher I've ever seen. I don't really know exactly how it works, but I think it just scrubs and polishes both sides of the parts, removes all the oil, so it's all ready to go. There's work storage back here, but everything on this table here, before forming them, gets put on this conveyor and goes through. It makes a lot of noise and comes out shiny. So that's about as sophisticated as I can tell you. So it is what it is. I just know what it does. Weird. If you're like a short-footed dog, I can't even get down these things.
No, you cannot.
Okay, begin. We're going to see a couple of CNC machines here. We're in the basement. It is a huge machine. We just walked down some skinny little stairs. So most of the stuff here was built in place. And a lot of it built by Martin. You can see examples of the 4130 steel. There's a ton of it here. And all sorts of parts that get laser cut out. Everything was just the size of the computer just to run it. And the machine itself. And all the different parts the evidence of all the parts that are already made. Maybe we'll see it in operation later. Add a clip. Let's keep walking. This is kind of interesting. How much nesting, using nesting software to maximize the utility of the steel, minimize the waste. Parts inside parts. This also has attached to it a 3D tube bender. It's not a bender, excuse me. It's a lathe. So the tubing, especially if you're making some tube and fabric aircraft, the tubing can all be cut, and I don't remember the term exactly now, but how it's fluted to match another piece of tubing before welding. And that's all done by CNC to have it match perfectly. Here's an inventory of a lot of tubes. Not much light here, but another one of the CNC machines for cutting. And here's an oven for heat treating. Some parts need heat treating. Pins and some sandblasting. I don't know, that looks like an ice cream fridge. I have no idea what that does. And, a lot more inventory and parts. Now, with anytime you make a rudder pedal or some type of welded assembly, everything, like engine mount, they all need an assembly jig. You just can't hold two pieces of steel together and weld it. So there's dozens, if not hundreds, of welding jigs in this inventory, where they'll have all the parts, put them all together, clamp it down, all held perfectly to make that final assembly. If it's a gear mount or an engine mount or a rudder assembly or a control stick, everyone has its own jig. And then there's a welding shop. They're setting up a new welding shop, so I'm not sure we'll see what that looks like. But here's part of the welding shop down here. So come on down and take a look. There's more steel storage. Here's another rabbit hole. And we're not done with rabbit holes. They're all where we have a really nice belt saw. And everything has a drawing and a jig. Here's an example of a jig for the dual controls, another jig for another assembly. And there's a nice lathe. How they got that? It's down here, I have no idea. But they did. And just continue. We're going deeper and deeper. Good if we could find the light switches.
No lights in here. Oh, beautiful.
Now this is actually a very important room, and it's really hard to tell that one. But take a look at this crane. That's not really to lift things. That's to break things. What we have, okay, we had quite a brief technical interruption there as the camera timed out. But we're continuing the testing room where we came down to the deepest rabbit hole there is here. And this is a pretty cool room. This looks like a medieval torture chamber in all aspects. You can take a look over here to get a close-up of this. This would be where we attach the main wing spar and the rear spar and put a wing over here and then attach this fixture, the inspection machine. And the old school way, the way I used to do this, we would take sandbags and bags of lead and load up a wing. You have to test it. It's a lot of weight near the root and tapers down to the wing tip. And we test it, we get it to the 4G, which is the design limit load, and then we unload it, and the test is that there's no permanent deformation, and it passes the design limit load, which nearly every design will do, unless they're really bad, and ours aren't really bad. And then we take another test. Take a close-up of this. This picture shows how that load is distributed on the wing with different forms, and also doing a flap and aileron measurement test. So you do tests at different part components of the wing as well. But the real test is the ultimate limit load, 50% above design limit load, which in most cases is 6 Gs. So we load this up not with the sandbags, but with that jig system where we just crank this up and put more pressure on it until it's calculated at 6 Gs. When you get to that last 6 Gs exactly at that, it has to hold for 3 seconds without breaking. So you hold your breath for 3 seconds, and then it passes, and then there can be some deformation, but it just can't break. And that's a big success when it does that, and then you can go ahead and beer. And the whole airplane, you can see there's jigs and fixtures all over for testing. Everything we do is properly tested. So we don't use any animals in our product testing or customers. So we'll just move on now to the next wrap mold. Okay, and this is the biggest big ass riveting machine I've ever seen. We put some pretty big rivets in with something like that. And there's another press brake that's used out of here. We have a bunch of storage huts outside for the working process. Here we've got the electric Sling 50 that was all set up to do the weight and balance to get the position of the electric motor and position of the batteries. That project's going ahead. And then we have the second Merlin light, which I've just finished the panel on. If we come a little closer, maybe we should move that up. Put this on full so you can see it's all ready to be lifted up. And we're doing the brake system now because when we get to Florida, we'll show it on floats, but then we'll fly it on floats and then put it back on wheels for the customer that will have this aircraft. Let's take a closer look at this. You can see how clean the engine insulation is. 38 horsepower cleaning, 303 DS for dual spark with the clutch. Pretty nice motor, 38 horsepower on this. And again, flying at 4,700 RPM is about half the RPM. And a two-stroke with that steep power curve, that's 35-40% power, which is going to keep it down around, I don't know, 14 horsepower to fly at 63 miles an hour. And come over here if you're still filming. This one's got the parachute. It's an option, but most customers will buy it. And then we've got that beautiful brake throttle system going in. The panel I've already done. We'll get I'll screw that in and turn it on for you later. And lots of baggage area, even with the parachute. It's some unusual in ultralights that you can actually carry a camping gear or your carry-on, full-size roll-on, not just your lunch. There's still protective film on that screen. And then we have a couple props all ready to go back there. So we're going to be shipping in about a week. Signing off, Chipper Aeromarine, Tech Pro Aviation, Olomouc, Eastern Czech Republic, which is also Moravian region. Cut. And then go have a beer.